In 1977, a remarkably preserved 6-month-old baby mammoth carcass was discovered in a state of deep freeze. Additionally, another mammoth from Beresovka, Siberia, was found with daisies in its stomach. Many specimens were found frozen in place, some with food still in their mouths and stomachs, suggesting that they froze due to an abrupt and rapid temperature decline. Research has pinpointed the date of their demise to approximately 12,000 years ago. Currently, accumulating evidence lends support to the hypothesis of a cosmic object impact, likely a comet, on Earth during this timeframe, known as the Younger Dryas impact, with the subsequent era termed the Younger Dryas event. This impact event could have resulted in a global flood and extensive earthquakes, ultimately leading to the destruction of land masses. This is particularly relevant to discussions about Atlantis, as the Younger Dryas impact is believed to have occurred between 10,800 to 10,900 BC, aligning with the proposed date of Atlantis's final submersion. The Younger Dryas period is estimated to have lasted from approximately 12,900 to 11,600 years ago, spanning about 1,300 years. During this period, an exceptionally unusual cooling event occurred, resembling a mini ice age, resulting in a temperature drop of approximately 15 degrees Celsius. The Younger Dryas period stands out as one of the most remarkable cooling events in the past 2 million years. This prolonged spell of extreme cold led to a mass extinction event among large animals, collectively referred to as megafauna. Tens of millions of these large animals, including mammoths, Irish elks, and saber-toothed tigers, vanished from the Earth. Globally, human population levels declined by an estimated 30 to 60%. The possibility of mass extinctions resulting from global cataclysms is not unique. Science has identified 5 mass extinction events, with the most recent known as the Cretaceous-Paleogene extinction around 66 million years ago, which is the most famous due to its association with the extinction of the dinosaurs. This event was likely caused by a combination of factors, including a massive asteroid impact in Mexico that led to widespread volcanic eruptions, resulting in the extinction of around 75% of Earth's species, including the non-avian dinosaurs. To gain a sense of what a cosmic impact entails, we can examine some relatively recent examples. In 2350 BC, an event referred to by scientists as the 4.2 kiloyear event or the Middle East anomaly occurred. This event, spanning at least a century, stands as the most severe climate change event in the past 10,000 years. It was triggered by a comet impact in the Boum al-Batini Lake in southern Iraq, which obliterated the city of Akkad, the capital of the Akkadian Empire in Mesopotamia. The immediate aftermath of the impact was marked by wildfires, floods, and an enormous air blast equivalent to over 100 megatons of power, which is equivalent to 6,000 Hiroshima atomic bombs. This colossal impact event caused global agriculture to suffer from prolonged droughts, rapid cooling, and crop failures. The consequences were felt worldwide as great civilizations in Mesopotamia, Egypt, Crete, China, and Latin America crumbled into anarchy and social chaos. The event likely triggered the Neolithic plague, resulting in the deaths of millions of people, which is a common occurrence following comet impacts. Additionally, during this time, the Great Chinese Flood and a period of severe drought were recorded. This intense drought affected regions across the globe, including North Africa, the Middle East, the Indian subcontinent, and the Central American glaciers in the western Canada mountain range. The life-sustaining waters of the Tigris, Euphrates, and Indus rivers were significantly reduced, leading to the transformation of fertile lands in the Middle East and Africa into arid, dusty regions that remain dry to this day. Notably, cuneiform tablets from Mesopotamia contain eyewitness accounts of the event. One tablet mentions that the monster, referring to the comet, was visible for 15 days before impact, and the ensuing destruction resulted in the blockage of the Tigris and Euphrates rivers. Another cuneiform tablet, part of the Epic of Gilgamesh, describes the terrifying storm and darkness caused by the event, with gods themselves fleeing to the highest heavens. The most recent major comet impact event occurred in the year 536 AD, characterized by extreme global cooling lasting for an agonizing decade. During this period, a mysterious fog blanketed Europe, the Middle East, and portions of Asia, plunging these regions into continuous darkness for both day and night. Syrian historical records report the sun appearing darkened, with this eerie darkness persisting for a staggering 18 months, leading to crop failures and ensuing hardships. Soon after, in 541 AD, the bubonic plague swept across the affected regions, claiming millions of lives. To determine whether a cosmic impact occurred at the onset of the Younger Dryas period, researchers seek various sources of evidence. For instance, a substantial impact event should leave behind a noticeable crater, and there should also be geochemical evidence, consisting of unusual chemicals or materials generated by the impact and remaining in the Earth's surface. Based on estimates, Earth has experienced a total of 16 giant comet impacts over the past 50,000 years. This implies that such large comet impacts occur approximately once every 3,000 years or so. One of the primary challenges in supporting the comet impact theory is the absence of a confirmed impact crater. This is not entirely surprising, considering that only 19% of Earth's surface is composed of land, with 10% covered in ice and a staggering 71% being ocean. For the Younger Dryas event, it is now believed that the first significant impact occurred in Greenland around 12,800 years ago, initiating the mini-ice age and drastically altering Earth's climate. Another impact, which marked the end of the Younger Dryas period and led to rapid global warming, struck the Puerto Rico Trench in the Atlantic Ocean approximately 11,600 years ago. The Greenland impact, known as Meltwater 1A, resulted in the melting of substantial ice masses, causing a temporary cooling of the oceans and a slowdown in the Atlantic Gulf Stream. In contrast, the impact in the Puerto Rico Trench, known as Meltwater 1B, triggered extensive earthquakes, volcanic activity, and ocean heating. This event brought about rapid global warming, and the massive rainfall and cloud cover it generated dispersed the dust cloud that had previously blocked the sun together. These two impacts created a seesaw effect, one cooled and froze the oceans, while the other boiled and warmed them. Gravitational anomalies are often indicative of significant impact craters. The Puerto Rico Trench exhibits one of the most negative gravitational anomalies on Earth. This intense gravitational pull causes deformations in the ocean's surface and can even affect navigational instruments. The Puerto Rico Trench is notorious for being part of the Bermuda Triangle and contains the deepest point in the Atlantic Ocean, known as the Milwaukee Depth. Given its proximity to tectonic plate boundaries, an impact in this region would likely result in widespread earthquakes, volcanic eruptions, and tsunamis, all triggered by the massive release of steam into the atmosphere due to the comet's impact. This, in turn, would cause months of relentless rainfall and cloud cover, leading to global flooding. These events could be the basis for the ancient legends of great deluges, which exist in countless cultures worldwide. Regarding geochemical evidence, various types of exotic material, potentially of impact origin, have been discovered. This material often appears as a conspicuous layer of discolored sediment, known as the black mat, at many sites across North America and beyond. Arguably, the three most compelling types of evidence include an abundance of iridium-enriched magnetic grains, nanodiamonds, and high levels of platinum group metals, such as platinum itself or iridium. These materials are rarely found in Earth's crust but are frequently abundant in comets. There is really no known alternative mechanism for producing a platinum group metal-enriched layer of dust over a large area of Earth's surface other than through a cosmic event like a comet impact, especially when it coincides with an abundance of nanodiamonds and magnetic grains. Indeed, an iridium abundance at the dinosaur-ending 66-million-year-old Cretaceous-Paleogene boundary helped to settle that debate. This layer, comprised of unusual chemicals most likely generated by a swarm of comet debris, has been discovered spanning 3 continents. According to the latest research, the debris field now extends from North America to the tip of South America and to the Near East, where we find the world's earliest megalithic monument, Göbekli Tepe, in southern Turkey. Astonishingly, it appears that the Younger Dryas impact event was recorded there through an early form of proto-writing inscribed on its giant stone pillars, and it likely served as inspiration for its construction. Specifically, Pillar 2 at Göbekli Tepe appears to describe the path of the Tauride meteor stream circa 10,000 BC. One of the most distinct geochemical signals of the impact is documented in a Greenland ice core, which exhibits a significant platinum anomaly precisely at the beginning of the Younger Dryas cold period, coinciding with a dramatic drop in the oxygen isotope trace, a proxy for temperature. The ice core date of 12,890 calories BP for this event translates to a calibrated date of around 10,870 BC. In 2015, a comprehensive statistical analysis of Younger Dryas sediments was published, establishing a date for the event of 10,835 BC, with a margin of error within 50 years at the 95% confidence level. This implies that the geochemical evidence aligns with a single event, most likely occurring between 10,785 and 10,885 BC, which closely corresponds to the platinum spike observed in the Greenland ice core. This research essentially settles, at least for me, that the Younger Dryas impact did indeed occur and was partially or fully responsible for the final sinking of Atlantis. Concerning the origin of this comet, it bears resemblance to the story of Phaeton, the son of the sun god Helios, who crashed the sun into Earth after recklessly piloting his father's chariot across the sky without permission. Phaeton is occasionally associated with a hypothetical missing fifth planet positioned between Mars and Jupiter, identified by various names in diverse mythologies, including Phaeton, Lucifer, and Marduk. It is plausible that the majority of comets and asteroids within our solar system are remnants of this shattered fifth planet. Another intriguing theory revolves around an unidentified celestial body, variably referred to as Nibiru, Planet X, or Hercolubus, purportedly making periodic entries into our solar system every 3,600 years. This celestial intruder's additional gravitational influence could have played a role in propelling cosmic objects along its path. I intend to delve deeper into this topic in a separate video. If you are keen on exploring this further, kindly remember to like and subscribe to my channel.